bond parameters. All these are bond parameters. We already completed last two parameters, bond order and dipole moment. Okay. In MOT, we completed bond order by using 14 electron table. Okay. Now let us start bond length. First bond parameter, bond length. Bond length. So let us abbreviate it as BL. BL. Okay. See, we will go with the general definition. General definition. Instead of textbook definitions, bond length, the distance between two bonded atoms. The distance between two bonded atoms is called as bond length. For example, let us take A is one atom and B is one atom. This length is called as bond length. Distance between two atoms in a molecule is called as bond length. This is general definition. General definition is enough. What is the original definition? The distance between two nuclei of bonded atom in a molecule, two nuclei. We have to take the, see, this is nuclei of one atom. For example, take here, this is B atom. The distance between the nuclei, this is one nucleus, this is one nucleus. Nuclei is the plural. The distance between the two nuclei of bonded atoms is called as bond length. This length. This is called as bond length. But let us go with the general definition. Okay. What are the factors which affects the bond length? Bond length. Factors affecting bond length. Factors affecting bond length. First one, radius. Radius or size. Radius or size. Second one, bond multiplicity. Bond multiplicity. Online students, are you following? Right. Radius or size. Second one, bond multiplicity. Third one, electronegativity. Electronegativity. Okay. First bond parameter, bond length. We completed definition of bond length and the factors affecting bond length. Coming to first one, size or radius. First factor, size or radius. Size or radius of atom. As size of the atoms increases, bond length increases. Bond length increases. See, under bond length only we can discuss bond strength also. Bond strength also. After completing bond length, we will discuss bond strength also. Simultaneously, bond strength also will be covered. Look at this one example. HF, HCl, HBr, HN. We know size of the fluorine, chlorine, bromine, iodine. Whose size is small? Fluorine size is small. Iodine size is bigger. So as size of the iodine increasing, bond length also increasing. So which is having greater bond length? Length between H and iodine. This length is more compared to bond length between H and F. Okay, x, y, z, some w. X, Y, Z, W represents bond length. Bond length. And what is the bond length order? What is the bond length order? Tell me. Bond length order. W greater than, Z greater than, Y greater than X. Very simple. Okay. And this is very important for second year P block elements. Remember all of you, this concept is very useful in the second year P block elements. Right. Another example, second example. Water molecule H2O. H2S. X, Y, Z. Did you identify oxygen, sulfur, selenium? What is the common point for these three elements? What is the common point for these three elements? This belongs to same group. Belongs to same group. Oxygen, sulfur, selenium, tellurium, polonium. Means down the group, what happens to the size? Size increases. So whose length is more? Z. Z. Bond length between selenium and hydrogen is more. So Z greater than, Y greater than. Radius or size affects bond length like this. Okay. Next. What I given next one? Bond multiplicity. Next factor is bond multiplicity only. No? Bond multiplicity. Bond multiplicity. Multiplicity is nothing but number of bonds. Bond multiplicity nothing but a number of bonds. Number of bonds. As the number of bonds increases, bond length decreases. Decreases. So bond length is inversely proportional to bond multiplicity. Bond multiplicity. Look at this. Hold on. Let us consider X is the bond length between carbon and carbon. Here number of bonds are more. Number of bonds are more. Means bond multiplicity is more, then bond length is less. So this length is less. X value is less compared to Y. Y value is less compared to Z. X is less than, Y is less than Z. So in alkynes, carbon-carbon bond length is less than alkenes. In alkenes, carbon-carbon bond length is less than alkenes. H2, O2, N2. X, Y, Z. Online students, can you give the bond length relation? X represent bond length between two hydrogens, Y represent bond length between two oxygens, and Z represent bond length between two nitrogens. Yeah. Hydrogen, in hydrogen molecule, two hydrogens are held together by single bond. Single bond. On oxygen, double bond. In nitrogen, double bond. So x greater than y greater than z. Next, write one important note. Once look at this, all of you. What is the relation between x and y? Once observe this example. You are taking length between oxygen and hydrogen in water molecule, and you are taking length between oxygen and hydrogen in H2O2. This is hydrogen peroxide. H2O2, hydrogen peroxide. See here how much distance is present in between hydrogen and oxygen. Here also same distance is present in between hydrogen and oxygen. For example, you both Priyanka and you are some sisters, okay? How much bonding present in between you in your home? Same bonding is present in college also, no? Place is changing, but bonding is not changing, right? Here, molecule is changing, but atoms are fixed only. You are taking length between hydrogen and oxygen only. That length is same, irrespective of the type of the molecule. In water or in H2O2 or in H2SO4, that length is same always. Clear? So, what is the relation between x and y? Is equal, x is equal to y. Why? You are considering distance between oxygen and hydrogen. Here also you are considering distance between oxygen and hydrogen. That length do not change. Molecule may change. Here, this is different molecule. H2O2 is different molecule. Water is different molecule. But you are considering length between H and O in same. Okay. This is very important. Okay. That is about a bond length. Another factor also there, na? Electronegativity. 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 Bond length is inversely proportional to electronegativity. Electronegativity. Look at this, all of you. Online students, are you getting? Hello? Online students. X, Y, Z, some W. So, X, Y, Z, W represent bond length. Bond length. Here, which is having more electronegativity? Fluorine is having more electronegativity. If electronegativity is more, then bond length is less. So, bond length order. X greater than, Y greater than, Z greater than W. Next, see, uh, based on bond length, we can discuss another parameter, bond strength. Bond strength. This is very useful in the secondary Pignac element. Just write as a subtopic. I didn't give main heading as bond strength, but you can keep heading here. Nothing will happen. Bond strength, very, very important. If you know bond length, you can compare bond strength. Before that, what is bond strength? Pranavi, what is bond strength? Energy required, simple definition. Energy required to break the bond. Energy required to break the bond. It's called as bond strength. For example, this is one atom and this is one atom. These two atoms are held together by a bond. This marker represents a stylus pen represent bond. Amount of energy required to break this is called as bond strength. Bond strength. See, we can say bond strength or we can compare bond strength easily, very, very easily. If two atoms are present very close to each other, then attractions are more between them. If two atoms are arranged closely together, then attractions are more in between them. Then you cannot break the bond easily. See, if two atoms are arranged with a distance, then attraction forces are less between them. You can break easily. So if bond length is less, both are attracted together tightly. You cannot break easily. If both atoms are arranged with a distance, then you can break easily. So what is the relation between bond strength and bond length? Inverse or direct? Inverse or direct? Bond strength hmm, is inversely proportional to bond length. If bond length is more, bond strength is less. Means if length between the atoms is more, you can break easily. You no need to use more energy to break it. Clear? If two atoms are arranged with a distance, large distance, you can break the bond between them easily. You no need to apply more energy. Bond strength is less. Why? Because both are arranged at a distance. Attraction forces are less. You can break easily. In fifth A group, sixth A group, seventh A group, even zero group also we use. Very important. Bond length idea, bond strength idea. Okay, now you are learning. Don't say, "Sir, I'm not having idea about bond length, bond strength." There we use directly this point. Okay, so remember all of you. I'll give you one example. I'll take a fifth year group only because there also I take same example. Now I'm taking that example so that the two times it will be revision for you. First of all, tell me bond length. What is bond length order? Let us compare bond length. NH, PH. This is bond length. I given at the beginning bond length. As size increases, bond length increases. This much size is large, so bond length is more. Bond length is more. If bond length is more, then bond strength is less. You no need to apply more strength. With less strength, with less energy, you can break. Which bond you can break easily? Online students. Which bond you can break easily? Online students. Bismuth and hydrogen bond. You can break this bond easily because length is more. Length is more. X, Y, Z, W, some M, and random alphabet. So bond strength. BS represent a bond strength, which is having more bond strength. Which is having more bond strength. X, X value is more. Why X is more? Because distance between nitrogen and hydrogen is very less. Nitrogen and hydrogen are tightly held together. You cannot break easily. You have to give more energy. So bond strength is more. So bond strength are X greater than Y greater than Z greater than W greater than M. So the benefit from chemical bonding, one will get one question from the bond parameter, and one question without any doubt. In second year, we will get another question. So that is the use of bond parameter. These are like basics for second year P block and direct question from the chemical bonding also. That is bond strength. Next, in molecular orbital theory, you learnt bond order and bond strength. I given already. Once I will revise. Another note. Bond strength is directly proportional to bond order. Bond order means you tell me already bond order is over. Bond order is over. What is bond order? Bond order means number of bonds between two atoms. Between two atoms. Number of bonds between two atoms is called as bond order. See this HH. What is the bond order? N double bond, so rho double bond O, N double bond N. Here bond order is less. Here bond order is more. Here more and more. If bond order is more, then bond strength is more. Which is having more bond strength? Nitrogen is having more bond strength. Already MOT, in MOT we discussed about bond order. Once revise it. Okay. If bond order is more, then bond strength is more. Okay. Right. What we are discussing? We are discussing bond parameter. Which bond parameter we are discussing? Bond length. We are discussing bond length, right? Correct only, no? Right. See, another important topic is resonance. You know already resonance in organic chemistry. But in chemical bonding also we have resonance topic. Okay. Not related to organic. This is general resonance topic. And what is the relation between resonance and bond length? Bond length. We are discussing bond length. Under bond length, we covered bond strength also as a subtopic. Again, we are covering another subtopic, resonance. Resonance and bond length. What is the relation between them? See, once look at this, all of you, all of X, Y, Z. X, Y, Z represents bond length. Bond length. What is the relation between X, Y, Z? Carbon carbon single bond length is more. Carbon carbon single bond length. You know already bond multiplicity. If bond multiplicity is more, bond length is less. I already given. X greater than is equal to Z or in general. This is single bond or double bond. Single bond or double bond. X greater than Y, no doubt, no doubt. Similarly, can we write Z greater than Y? Can we write like that? Z is also single bond only. So X is equal to Z. In general, I am asked. This is single bond, this is also single bond. So we can write X is equal to Z, but that won't happen. Okay. Here resonance is present. Resonance is present or not? Alternative double bonds. Resonance is present or not? If resonance is present, then bond length will change. Okay. Now let us keep adding resonance. It is related to chemical bonding, not organic resonance. Definition is same. Definition is same. Representing one molecule in various electronic arrangements is called as resonance. Representing one molecule or ion in various electronic arrangements. In various electronic arrangements. Is called as resonance. Is called as resonance. I'm taking one ion, CO3 minus, CO3 minus. Let us represent this ion in different electronic arrangements, various electronic arrangements. Representing one ion or molecule in various electronic arrangements, in different electronic arrangements, or simple thing, representing one ion in different structures or by different structures is called as resonance. Simple terminology. Take one molecule, represent that molecule with different structures. That phenomenon is called as resonance. Or another simple definition, writing different structures for one molecule or writing different structures for one ion is called as resonance. Very simple definition. Now we are drawing different structures for CO3 minus 2. That phenomena, the drawing is called as resonance. Girls, if you don't know the structures, when you get the structures of polyatomic ions like CO3 minus 2 with charges, what you have to do? So I'll tell you one trick to you. First write central atom. Central atom is carbon. How to identify central atom? The atom whose atomicity is less is called central atom. Only one carbon is present, that is central atom. Atomicity is less, one atom only. Oxygen atomicity is 3, that is not central atom. The atom whose atomicity is less or less electronegative atom acts as central atom. The atom with less atomicity or the atom with less electronegativity acts as central atom. Remember that point. If you don't know how to draw the structures, follow this technique. First write central atom. Remaining surrounding atoms are there. How many surrounding atoms are there? 3 surrounding atoms. Write with single bond. Write surrounding atoms with a single bond. Okay. If you don't know structure, what you have to do? First write central atom and write surrounding atoms with a single bond. Single bond. Observe the charge. What is the charge, online students? Online students. Charge. Negative. How many negative charges are there? 2 units negative. No. 2 negative charges are completed, right? Is there any extra charge? No. This oxygen is not getting negative charge. The oxygen which do not get negative charge, keep double bond. Keep double bond. Okay. Now let us give numbering for the oxygen atom. First oxygen, second oxygen, and third oxygen. Give numbering. Okay. This is first resonating structure, right? Once look at this, all of you. You tell me, online students, double bond is present in between which two atoms? Carbon and oxygen. What is the number of that oxygen? First oxygen or third oxygen or second oxygen? Second oxygen. Now, second oxygen. Now we can write this double bond between first oxygen and carbon. That is one possibility. Yes or no? After that, we can write the double bond between carbon and third oxygen. So, how many resonating structures we are getting? More two, more two. So, you can write double bond between carbon and second oxygen, or you can write double bond between carbon and first oxygen, or carbon and third oxygen. So, more two resonating structures will possible. Another one. See, importance is there. How to draw resonating structures is very important. I'll tell you. Very, very important. That's why I'm explaining. Next, we can keep double bond in between carbon and soda. This is second oxygen. Okay, I'll tell you one simple trick. In CO3 minus 2, how many surrounding atoms are present? How many surrounding atoms are present? Online students, how many? Three surrounding atoms. So three resonating structures are possible. Number of resonating structures is equal to number of surrounding atoms. You can write that also if you want. You can write. Number of resonating structures. Number of resonating structures is equal to number of surrounding atoms. Okay. Why we are drawing the resonating structures? What is the need to draw the resonating structure? You know bond order. What is the shortcut method for bond order, guys? What is the shortcut method for bond order? 14 electron table. If number of electrons are 3, then bond order is, sorry, number of electrons are 14, bond order is 3. I given 14 electron table because you are focusing on practicals and IPE. That's why response is very less. From online and offline also both. Okay. No, we keep on preparing IPE. Okay. After IPE only you start your preparation. No problem. Okay. Priyanka, once look at this. This is X. This is Y. This is Z. Whose bond length is less? Here in this structure, in first structure, first one, this is 2, this is 3, right? In first resonating structure, whose bond length is less? X, Y, Z, which is less. X represent bond length between carbon and oxygen. Y represent bond length between carbon and this oxygen, first oxygen. Z represent bond length between carbon and third oxygen. Online students, whose value is less? X, Y, Z, whose value is less? X. Why? Because that is double bond. Double bond length is always less. Double bond length is always less. Okay. Right. Right. See, fix X in all three. X represent bond length between carbon and which oxygen? First or second or third oxygen? Second. We are fixing. Second, right? Carbon and second oxygen bond length is considered as X. Carbon and second oxygen bond length is considered as X. In first resonating structure, what is X? Double bond or single bond? Double bond. In second resonating structure, it is becoming single bond. Single bond, right? Here X value is less, actually because double bond. Here X value is more, single bond, single bond. Okay. Next, coming to Y. In first resonating structure, Y value is more because Y is single bond here. But in second resonating structure, less. Why? Because that is double bond. So why it is happening? Due to resonance. All these are resonating structures. Because of resonating structures, all bond lengths are same in CO3 minus 2. See, in one resonating structure, X is double bond. In another resonating structure, X is single bond. So overall, all the bond lengths are same. Here, this double bond is converting into single. Here, where it is, this double bond is converting into single. These all bonds are changing continuously. So overall, all bond lengths are same. Bond length between carbon and first oxygen, carbon and second, carbon and third is same due to resonance. So very important point. If resonance is present, then all bond lengths are same. In CO3 minus 2, all carbon oxygen bond lengths are same because here X is having double bond character in first resonating structure. But here that same X is having single bond character. So double bonding is changing into single bond is changing into double bond. So overall all bond lengths are same. So final conclusion, if resonance is present, then all bond lengths are same. In CO3 minus 2, what is the nature of bond length? Same or different? Same. If resonance is present, then all bond lengths are same. So final conclusion, what is the relation between XYZ online students? What is the relation between XYZ? Huh? X, X is equal to Y is equal to Z. So if resonance is present, then all bond lengths are same. You take another example also. Another example for resonance. SO4 minus 2. In SO4 minus 2, resonance is present and all bond lengths are same. PO4 minus 3. Here also all bond lengths are same. And benzene, very, very important. In benzene also resonance is there. Alternative double bonds are present or not? In 1,3-butadiene, look at this all of you. All carbon-carbon bond lengths are same. Where resonance is present? In which molecule resonance is present? In that molecule, all bond lengths are same. All these are having same bond length. Same bond length. One special person. Okay, generally we write normal skull, but special skull. Very, very, very important question. Okay. O3, O3, O2, oxygen molecule. H2O2, hydrogen peroxide. Bond length comparison is very, very, very important. Bond length comparison of these three. Okay. Everyone should know about ozone structure. Once upon a time, you have ozone preparation methods also. Okay. In secondary, you have ozone preparation for IP secondary students. So this is ozone structure. Positive, negative, positive, negative. Let us give numbering. First oxygen and the second oxygen. Now you tell me, this is for only ozone. We are drawing the structure of ozone only. In ozone, we have three oxygens. One oxygen atom acts as central atom. Remaining two acts as surrounding atoms. Now you tell me, double bond is present in between central atom and the first oxygen, right? Here oxygen only central atom, oxygen only surrounding atom. In ozone, oxygen only central atom, oxygen only surrounding atom. Now tell me here double bond is in between central atom and first oxygen. Can we keep double bond between second oxygen and central atom? Yes. So one resonating structure is possible. Sorry. Second oxygen, right? This is negative charge. Sorry, keep negative charge. How many resonating structures are possible for ozone? Tell me. Make it fast. How many resonating structures are possible? Two resonating structures are possible. Very, very important. Okay. In O2, this is about O3 structure. O2. Everyone knows about O2. O2 structure. O double bond O. O double bond O. And H2O2. Open book structure. Hydrogen peroxide. Sometimes you have to remember the structures even though you do not have that compounds in your regular objective syllabus. But you have to remember this is structure of hydrogen peroxide. Open book structure. Open book structure. Okay. X Y, Z, X, Y, Z. We are comparing the bond length between two oxygen atoms in three different molecules: ozone, O2, and hydrogen peroxide. Anybody, can you try? What is the relation between X, Y, Z? What is the relation between X, Y, Z? First of all, which is single bond? Z is Z is Z is greater. Who said that? Ketra, you only. Someone are giving answer. Who is that? Akshara, you? Yeah. Well tried. Yeah, well tried. This is single bond. Single bond, bond length is more, no doubt, no doubt. Z greater, Z greater. Next. Hmm. This is X. X is double bond, but after some time, what is happening? You tell me. The double bond is converting into single bond. After some time, single bond will convert to double bond because both are resonating structure now. So this equilibrium will exist between them. So double bond converted to single bond converted to double bond. So bond length character is intermediate between double bond and a single bond. Here bond length is intermediate between single bond and a double bond. Is there any resonance here? It is always present as a double bond. Double bond length is lesser. Less. So Z after X will come. X after Y. X bond length is intermediate between single bond and double bond, intermediate. But here, this is always double bond, always less one. Here, this is intermediate between single bond character and double bond character. That's why after Z is always single. Z is always single. There is no resonance. That's why Z value is greater. Here it is intermediate between single bond character and double bond character due to resonance. So X will come. After that Y. Y is least. Y always double bond, always less. Clear? Very, very important comparison. Right. You know how to write resonating structures? Yes or no? Everyone knows about how to write resonating structures. 5 star. Bond order. Bond order in polyatomic ions. Bond order in polyatomic ions. Bond order in polyatomic ions. Let us take CO3 minus 2 example only. CO3 minus. What is the bond order in CO3 minus 2? First of all, oh, let us write the formula for bond order of polyatomic ions. In general, we use 14 electron table or MO2, molecular orbital theory, sigma 1s, sigma star 1s. What is the formula? What is the formula? Normal formula, bond order is equal to number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbital by 2. This is general formula, but by using this formula or MO2, you cannot find bond order for CO3 minus 2. This is a polyatomic ion that are applicable for diatomic. This O2, N2, you can apply this formula for these, but not for polyatomic ions. Then how to find bond order in polyatomic ions? See the formula first, all of you. Bond order is equal to number of bonds between atoms by total number of resonating structures. Resonating structures. Number of bonds between two atoms. Actually, bond is present in between two atoms only. No? That's why. Number of bonds between atoms divided by total number of resonating structures. How to find resonating structures? I given one hint. How to find resonating structure? Based on the subscript. Subscript. Here what is the subscript? 3. Surrounding atoms. Subscript nothing but surrounding atoms. How many surrounding atoms are present? 3. So 3 resonating structures. So no problem with number of resonating structure, but the problem with the number of bonds between the atoms is the problem. How to find number of bonds? I given one hint, one trick to write to draw the structure. Let us draw the structure. CO3 minus 2 structure. Tell me all of you. Carbon, oxygen, oxygen, oxygen. How many negative charges are there? How many? 2 units negative charge. 2 units negative charge. So negative, negative. I already given this before that. If oxygen do not get any charge, it will get a double bond. It will get double bond. Over. No. Substitute in the formula. Bond order. Count number of bonds between the atoms. 1, 2, 3, 4. 1, 2, 3, 4. 4 divided by C. Subscript or number of surrounding atoms. 4 by 3 means how much? 1.33. Important. Bond order for polyatomic ions. You try this. You try this, all of you. SO4 minus. Try this. SO4 minus. Online students. Online students. 1.5. See the solution. SO4 minus 2. How to draw the structure? Sulfur. How many surrounding oxygens are there? 4. Negative charges? 2 negative charges. Minus 2. Keep here one negative, here one negative. But these two are not getting negative charge. Then what we have to do? Write double bond. So bond order is equal to number of bonds between the atoms. Count 1, 2, 3, 4, 5, 6. 6 divided by total resonating structure. How much? 1.5. 3 by 2, no? 1.5. Okay. This is about the bond order of polyatomic ions. Bond length is over. Bond length and bond strength also completed. Next, bond angle. Bond angle. Bond angle. Let us consider AB2 molecule. AB2 molecule. Consider the structure of AB2 present like this. Bond angle, definition of bond angle. The angle between two adjacent bonds is called as bond angle. The angle between two adjacent bonds in a molecule is called as bond angle. Simple definition, angle between two adjacent bonds. Is called as bond angle. Bond angle question was repeated a number of times. Okay. What are the factors affecting the bond angle? Factors affecting bond angle. First factor, hybridization. Hybridization. Second factor, electronegativity. Electronegativity. Third factor, size. Third factor, size. Hybridization, electronegativity, and size. Okay. Hmm. You know about hybridization very well. Correct, Priyanka? Online students, tell me. If you observe USP hybridization, then what is the bond angle? Hmm. Online students. Online students. If you observe SP hybridization, if you observe SP hybridization, 180, 180, 180. Here, 120. Here, 109 degrees. One exceptional case is there, very important, right here on, right here on, right like this exception. Even though hybridization is P3, but bond angle is not 109 degrees 28 minutes. What are the two exceptional cases? We have two exceptional cases. What are that? Here hybridization is sp3 only. Here also hybridization is, sorry, here also hybridization is sp3 only. Both are having sp3 only, but don't take bond angle as 109 degrees 28 minutes. You have to by heart the data, bond angle data of ammonia and water. I already said that during hybridization concept explanation. Tell me what is the bond angle here? 107. Daily you have to read some time in organic, physical, physics, botany, zoology, all subjects. You keep your hand for 1 month like this only on the bed, like this. Practical information that keep without doing any work. After that, you will get more pain and your hand will not work. Okay. Similarly, if we do not give new things to our brain, if we stop learning new things, if we stop revising, our brain function will decrease. You will get memory problems also. Memory problems. So daily you have to give the input and you have to check yourself. Okay, IP is also important. What I am saying, I think it is not possible, but if you try, then you will be different. Some students will say, sir, we are having IP, our total focus is on the IP. But once imagine after IP, okay. H2O, 104.5. Okay, we'll continue tomorrow.